Hello students, so this is the 9th video of third module, that is memory systems. So in the last video I was explaining you about the set associative mapping. So there are three different mapping functions. So how the data from the main memory, it will be transferred to the cache memory when it is being requested by the processor. So here this mapping functions will be done in order to increase the performance by decreasing the time taken to get the data from the main memory to the processor, in which the processor has to wait in order to read the memory or the write the particular part of the memory. So here we are aware of what is the direct mapping and set associative mapping. So this set associative mapping, it is combination of both associative mapping as well as direct mapping. So here we can see how actually it works. Blocks of cache are grouped into sets here. So mapping functions allows a block of the main memory to reside in any block of a specific set. Divide the cache into 64 sets with 2 blocks per set, memory block 0, 64, 128, like that, and map to block 0, and they can occupy either of the two positions. Memory address is divided into 3 fields here. So 6-bit field determines the set number. High order 6-bit fields are compared to the tag fields of the two blocks in a set. Set associative mapping, combination of direct and associative mapping. Number of blocks per set is a design parameter. One extreme is to have all the blocks in one set requiring no set bits. Fully associative mapping. Other extreme is to have an one block per set is the same as direct mapping. So this is about the set associative mapping. So next, coming to the performance consideration. So a key design objective of a computer system is to achieve the best possible performance at the lower possible cost. So price or performance ratio is a common measure of success. Price by performance ratio is a common measure of success. Performance of a processor depends on how fast machine instructions can be brought into the processor for execution, how fast the instructions can be executed. So these are the two parameters on which we can judge the performance of a processor. So first one is how fast the machine instructions can be brought into the processor for execution, and second one is how fast the instructions can be executed. So here we will see how actually it is done. Interleaving. First thing is interleaving. It divides the memory system into a number of memory modules. Each module has its own address buffer register and data buffer register. So here what we are going to do means we are going to divide the memory system into the number of memory modules. Each memory module has its own address buffer register and also data buffer register. Arranges addressing so that successive words in the address space are placed in different modules. When requests for memory access involve consecutive addresses, the access will be to the different modules. Since parallel access to these modules is possible, the average rate of fetching words from the main memory can be increased. So how these address layouts will be there? So there are two different types. So here you can see module and address in module. So k bits is for modules and address in module is m bits. So here you can see module 0, ABR and DBR. ABR is address bit rate and buffer address buffer register, and DBR is data buffer register. So here you are going to divide the entire memory into the different modules. So consecutive words are placed in a module. High order k bits of the memory address determine the module. Low order m bits of the memory address determine the word within a module. When a block of words is transferred from main memory to cache, only one module is busy at a time. So here in this type, what we are going to do is m bits of address in the module, and modules are of k bits. So here you can see consecutive words are located in the consecutive models. Consecutive addresses can be located in the consecutive models. While transferring a block of data, several memory modules can be kept busy at the same time. So here only one module can be kept busy. Here several modules can be kept busy. So this is a different address layout methods. Next is hit rate and miss penalty. Hit rate can be improved by increasing the block size while keeping cache size constant. So hit rate means whatever requested data, if it is present in the cache, then we call it as a hit rate. So this hit rate can be increased, it can be improved by increasing the block size while keeping cache size constant. Block sizes that are neither very small nor very large give best result. Miss penalty means if it is not present, if the requested data is not present in the cache memory, then this miss penalty occurs. So this miss penalty can be reduced if load through approach is used when loading new blocks into the cache. So cache on the processor chip. In high performance processor, two levels of cache are being normally used. The average access time in a system with the two levels of cache is T average equals to H1C1 plus 1 minus H1 H2C2 plus 1 minus H1 1 minus H2M. Then next comes other performance enhancement, how we can improve the performance. So we'll see in write buffer, write through. Each write operation involves writing to the main memory. If the processor has to wait for the write operation to be complete, it slows down the processor. Processor does not depend on the result of the write operation. Write buffer can be included for temporary storage of write requests. Processor places each write request into the buffer and continues execution. If a subsequent read request references data which is still in the write buffer, then this data is referenced in the write buffer. So write back block is returned back to the main memory when it is replaced. If the processor waits for this write to complete before reading the new block, it is slowed down. For fast write, buffer can hold the block to be returned and the new block can be read first. So other performance enhancements, prefetching is also included. So new data are brought into the processor when they are first needed. Processor has to wait before the data transfer is complete. Prefetch the data into the cache before they are actually needed or before a read miss occurs. Prefetching can be accomplished through software by including a special instructions in the machine language of the processor. Inclusion of the prefetch instruction increases the length of the programs. So prefetching can also accomplish using hardware circuitry that attempts to discover patterns in memory references and then prefetches according to this pattern. So next is the lock up free cache. Prefetching schemes does not work if it stops other accesses to the cache until the prefetch is completed. A cache of this type is said to be locked while it services a miss. Cache structure which supports multiple outstanding misses is called as lockup free cache. Since only one miss can be serviced at a time, a lockup free cache must include circuits that keep track of all the outstanding misses. Special registers may hold the necessary information about these misses. So this is about the performance and the lockup free cache. So this is the end of the our module memory systems. Thank you.